In this video, we're going to talk about piecewise functions. A piecewise function it's like a combination of more than one function at different points in the domain. So a piecewise function is a function in which the domain is divided and represented by pieces of various functions, represented by pieces of various functions. And so what we're going to look at now is we're just going to start by looking at evaluating functions that are piecewise functions at the indicated value. So here's what we do. This is an example of a piecewise function. F of x is equal to, and then when it's a piecewise function, we do just a single brace, and then we put the various function pieces one above the other. So first we have x plus 3, and it's only going to be x plus 3 when x is less than 0. And then it's going to be negative x minus 5 when x is greater than or equal to 0. So it's basically taking this function, we'll call it v. V of x is equal to x plus 3. And then w of x is equal to negative x minus 5. So it's just these two functions, but in one single function, and then one of these stops and the other one then starts back up. So that's kind of what we're doing here. Now, when we're evaluating specific points, we only plug in numbers that are less than 0 to the top piece. We only plug in numbers that are bigger than or equal to 0 into the bottom piece. So again, this is a function. Every input has one output. So for example, here we want to determine what is f of negative 2. Well, first we have to decide which piece does negative 2 belong to. Is negative 2 less than 0? So is this true? Or is this true? Only one of these can be true, and it turns out the top one is true. This is true and this is false. So that means we only plug in negative 2 into the top piece. So negative 2 we're going to plug in here into negative 2 plus 3. And so that would be positive 1. So this would be the ordered pair negative 2, comma 1. We only plug it into the piece that it belongs to as defined by the inequality given on the right-hand side. Next, f of 0. So now we only plug in 0 either here or here. Which one of those is true? Is 0 less than 0? Or is 0 greater than or equal to 0? This one's true. 0 is not less than 0. 0 is greater than or equal to 0. So we only plug in 0 to the bottom part of the function. This would be negative 0 minus 5. That would be 0 minus 5, which would be negative 5. So this would be the ordered pair 0, negative 5. Then lastly, we want to evaluate the function at 6. So again, we decide where does 6 belong, which piece. Is 6 less than 0? No. Is 6 greater than or equal to 0? Yes, it is. So we only plug in 6 to the bottom piece. That would be negative 6 minus 5, which would be negative 11, or the ordered pair 6, negative 11. Looking at example B. So example B, this one's a little bit more intense. It's a 3-piece piecewise function. Our first piece is defined when x is less than or equal to negative 4. The second piece is in between negative 4 and 2. And the third piece is when x is bigger than 2. So first we're looking at h of negative 6. Where is negative 6 true? Is it true here, where it's less than or equal to negative 4? Is it true in the middle, that it's in between negative 4 and 2? Or is it true here that it's bigger than 2? Negative 6 is smaller than negative 4, so it makes a true statement in that top piece. So we only plug in negative 6 to 1/2 x plus 7. So h of negative 6 is 1/2 times negative 6 plus 7. Half of negative 6 is negative 3, and negative 3 plus 7 is 4. So this would be the ordered pair negative 6, 4. And that's it. We only plug in negative 6 to one of the three pieces, the one that it makes a true statement. That's where it made a true statement. All right, so that was part 1 of B. In part 2, we're looking at h of negative 4. So we have to decide where is negative 4 in these three pieces. Is negative 4 less than or equal to negative 4? Yes, it is. It is not less than itself, so we're only going to plug in -4 into the top piece. That's the only place where this is defined by the function. Half of -4, -2 plus 7 is 5. For our third example, we have h of 0. So now we need to decide, where is 0 defined? Is 0 less than or equal to -4? No. Is 0 in between -4 and 2? Yes. So that means we only plug in 0 here to this middle piece. And the middle piece, actually, we don't even have to plug in 0. There's no x's to plug it into. That means that this particular segment is a horizontal line segment, just going straight across at -3. So it would be -3, and that's it. Or the 0, -. Two more. Number 4 is asking us to determine what h of 2 is. So where is 2? Where does it make a true statement? We know it's not that top one. Is 2, -4 is less than 2, which is less than or equal to 2? Yes, 2 is less than or equal to 2, so we would plug it into the middle piece. If you look at the bottom piece, 2 is not greater than 2, so it would be incorrect to plug it into the bottom piece. Again, since this is just a horizontal line segment, h of 2 will be -3, which is the ordered pair, 2, -3. Lastly, so h of 5, again, before we plug in, we need to figure out which one are we plugging into. So where does 5 fit in? Is 5 less than or equal to -4? No. Is 5 in between -4 and 2? No. Is 5 bigger than 2? Yes. Yes, it is. We plug 5 into the bottom function, bottom piece of the function, excuse me. So it would be 1 over 5 plus 3. 1 over 5 plus 3 is 3 1/5. So this would be the ordered pair, 5, 3 1/5.